Hello, this is Rich, and in this tutorial we're going to be doing something with Snappy again. Recently I've added support for animation using a proprietary animation system. It is based on a keyframe type. So let's get started. So what I want to do is I actually want to show you a working example. Pretty much just text that are being drawn, obviously with Direct2D. It's going to be doing a looping animation with starting from the top of the screen to the bottom, then to the left, to the right, and then over and over again. So it's going to be a scrolling text, almost like a marquee effect. So let's go ahead and load it up. You can see down here in the code, we have the event checking if we press the A key, and if we release it, we're going to spawn basically our multi-keyframe animation tester. So a little test class that has a predefined animation, and it's set to play as soon as it's spawned in its class. So what we'll do is we will push A, and we're going to watch it. And it's just an animation. I think this is like 20-second animation. So 10 seconds, 5 seconds to each side. So 5 down, 5 left, 5 right, 5 top. Let's hit the top. It's going to loop. Alright, beautiful. I can also move this window while the animation is still going on. So what you're seeing here is not basically an asset. What you're seeing is through code, animation through code. In the future, I do plan to provide some sort of UI to create animations with the user interface, but right now it's through code. And I just wanted to show you that. So right now we'll get out of that and we'll do something unique. Right here what we'll do is we're going to make an animation that will move the window when we press up on the key on the keyboard. We're going to move the window up, and we press left, we're going to move the window left. I'm going to press right, we're going to move the window right, etc. down. Okay, so here's what we're going to do. We're going to check for up key right now. So we're going to check if the P event that we receive, and by the way, we are in the onInput event in the main class. So the onInput is going to receive any input, and it sends in the event that happened, input event. So we're going to check the event for its arguments, and we're going to check for what key. And if the key equals ekey underscore up, oops, and we're going to check if the P event args happens to be released. E button state released. Beautiful. So if you press up key, and when we release it, we want the animation to happen. Well, we want it to go up, and then back to its original position. So let's go ahead and do that. Now, the main class, actually the only class in the animation system here, is called the animatable value, and this is very, very unique. It's pretty awesome. It allows animating of any data type, not just integers, floats, and all that. It actually will animate any class you give it, like a texture class or a vector class, anything. How it's able to do that is it provides some callbacks for you to process your manual interpolations on what it should do when it's interpolating from each keyframe to each keyframe. And I'll show you that. I'll show some manual interpolation here using our vector2 class here. So we're going to animate the position, which is vector2, and we just do animatable value because it is a template class. We type in the type we want to animate. Well, I do know that positions are stored in vector2i. So it's an integer. It's equivalent to that, vector2 int. So we have a vector2i here, and we're going to call it, we're going to dynamically create it on the heap here. P position and the reason why is because I don't want to do any cleanup code, and the class will get destroyed obviously if it's made on the stack at the end of scope. But I want to keep it for the tutorial, so I know it's going to cause a mem leak, but that's fine. We're in debugging mode; it should be fine. Equals new animatable value. We want to animate some vector2i's, vector2's, beautiful. And here what we're going to do for the constructor, we're going to pass in the animation length Okay, so how long in seconds? So it could be 1.1 seconds, 1.23 seconds. Okay, so we want this animation to be half a second, very quick. We don't want any looping, so we'll just pass false here, no looping. So here's what we're going to do. First of all, we'll take our position anim, all right, and we're going to add some keyframes. Well, we only want pretty much 3 keyframes. We want a keyframe from when we start, we want a keyframe when it's going up on its up position, and we want another keyframe to put it back down, so it's a nice smooth up and down back to its original. So let's go ahead and do that. So P position anim, and we're going to add a keyframe. Now there's many. I'll quickly go over these here. So we have add keyframe, which allows you to add a new value of vector 2i, because that's the type we chose. It tells us the keyframe at what time you want to put it at, let's say 0 seconds here, so for the time. The vector 2i value, second parameter, decides at that point in time what is the new value. The next one, which is the last, replace if exists. So if I already have a keyframe at 0 time, it will then replace it if I specify a new one, and that's if I do true or not. So we're going to add a keyframe, and we want to start the beginning position. So we're going to say it at time 0. Okay, so at time 0, we want to give it, well, what value? Well, we need to know the current value of the window. So let's go ahead and do that. So before here, let's go ahead and grab the window. You can do this by getting the main window. See, Snappy, you can have as many windows as you want, in fact, but you can set one as the active window, and you can retrieve that. So we'll do that. We're going to get the application, and then we're going to go ahead and get the main window here. And we're going to store that. So CUI window P main window. Beautiful. So now we have the window that's currently active. Also, the very first window that you create in Snappy will automatically become the main window. Any other windows you create after that will have to be manually set by using the set main window of the application class. So we'll go ahead and take the window. Now, since this is a window, and it's also UI control, with the UI control, you would generally use the get actual position and get actual height and all that. But this is a window, so it's going to be following the screen space, so the entire desktop. So for Windows, you're going to want to use the get handle position. So get handle is another function that will return the underlying HWND, underlying hardware window. But we want to get the hardware window's position because we're dealing with screen space with this window. So we're going to get the position of the window, and we're going to store that as a vector 2i. Vector 2i. I'm going to call it orig position. Orig position. Beautiful. Now we know the original position of the window. So we want to set our first keyframe at the original position. And do we want to replace? No, we're not going to replace it because we know we're only doing 3 keyframes and none of them will overlap. So we'll just give that default value of false. So then let's add another one. So we're going to start it with its current position. Then we're going to add another keyframe. And this is a half a second animation. So I want it to take 0.25. So a quarter of a second to go up and then a quarter of a second to go down. So where do we want it to be? Well, when we're pressing the up key, we want the window to go up. Well, let's say we want to take the original position plus vector 2i, 100. Beautiful. And we actually need to subtract. So what we're going to do here is on the second keyframe at 0.25 seconds, so halfway through the animation, we want the position to be 100 pixels above its current position. Beautiful. Now let's add the last keyframe here. And this is at the last, so 0.5 seconds, which is the entire animation here. In the entire animation, we want it to go back to its original. So as you can see, we're going to start, then we're going to go up, then we're going to go back down to the original position. Nice, smooth. Beautiful. So now we get the keyframes here. We tell it, okay, we want it to be this position, this position, this position. I'm at these keys. But now we need to let it know how to interpolate. It doesn't really know how to interpolate our vector2 class. Because again, we can interpolate any value that we want. That's what makes it so powerful. So we need to give it to take advantage of the callback we get. And there's a few callbacks. More will be added in the future. So one of the callbacks we have here, or the events, I have to call them events here, using the event system, is we have the on interpolation event. So we have the on done event here. I'll go over them quickly. On done happens whenever your animation is completely stopped, like 100%. Like when you actually tell it to stop, or when your animation reaches its end and looping is not enabled, you'll get the on done event. And it does pass you some parameters. It passes you the current value at when it was stopped and the current time, okay, of the animation when it stopped. We have the on end reached event, which gives you basically the mouse position, not mouse position. That's an IntelliSense error there. It does give you the current value. Since we are a vector2i animation, it will give us the current value whenever it reaches the end. Now, the on-end reach isn't particularly when it stops. That happens whenever the length of the animation has been reached. But if looping is enabled, this on-end reach will be, every single time the animation ends, on-end reach will happen. So that's when that event will be set up. So on interpolation event, this is the main one we're going to be dealing with here. So whenever the animation, so basically an animation is, so many seconds long, and the time continually advances as the animation plays. So pretty much whenever a frame happens, you'll get a new callback on interpolation event, and that gives you a place to interpolate what your new value should be at that point in time. And this is what we're going to be doing here. On next keyframe reached, that obviously whenever a new keyframe. So if I have, this event will happen whenever the current time is at 0, 0.25, and 0.5, I'll get this. So I'm able to get per keyframe callbacks here. And what I'll get is I'll get the current value of the vector2i. I'll get the global current time. So the global current time is different from the local current time. So global current time is like the animation is 5 seconds long. So if you're like halfway through, it'll be 2.5 seconds is global time. Local time, on the other hand, is the time between each keyframe. So let's say I have a 5-second global animation time. So the animation entirety is 5 seconds. But I have a keyframe on every single second. So I have 5 keyframes. The local time is a time between each keyframe. So between keyframe 0 and 1, if it's halfway done that, it would be, let's say, 0.5. So it would be halfway through, so 0.5. That's the local time. Okay, so if the keyframe 1 is on second 0 and the keyframe 2 is on second 1, it will be a 0.5. Okay. So local is in between keyframes, global is the entire animation length. So let's go ahead and handle this on interpolation event. Beautiful. So let's go ahead and subscribe to this event so we'll get callbacks here. And we'll just simply do a lambda function. Now, it is important to note, I'm doing a lot of repetitive work. Well, I will be. When I create the left, right, down animations, there'll be a lot of repetitive work for this callback. I could, however, for vector2i classes, I could create a static global function that will handle the vector2 class. That way, whenever I subscribe to an interpolation event and I'm interpolating a vector2i, I can just pass it that already made interpolation function. That way I don't have to keep creating a lambda for each one. You could do that. So what we'll do is we'll create a lambda here. So we'll make a new event handler. We covered the event system on the UI tutorial, I believe. Not UI. The networking tutorial. So here we go. So new event handler. Now we need to pass it the signature. Okay, so the signature of this callback. It's a long one. That's why using type defs can make things a lot shorter, but this is a long one because I do pass a lot of information, and just in case you want it to give a lot of extensibility. So on interpolation event, it gives you a start value, end value, which is your vector2i. Okay, so start value, end value,
the current local time, the animation local length, and then the vector2 return. Okay, so what we're going to do here is we're going to write that signature. Well, vector2i start value, vector2i end value, double for the local current time, and then another double for the local animation length, and then a vector2i pointer, which will hold the return value. That's because events cannot have a return value, so we're basically passing in a reference here so we can get the return. So there we go. Now let's go ahead and write our lambda. So the first parameter, obviously events, is the function that you want to call every time this event happens. And the second is just a friendly name you give it. So what we'll do here is we'll create a lambda. So bam, bam, just like that, like that, like that. That's a beautiful lambda. Let's go ahead and give it a name here for the second parameter. Second parameter, we'll just call it the position handler, position anim handler 1. Now remember, this is a friendly name that will allow you to unsubscribe at a later point. So we'll be able to unsubscribe from this event using this name here. That's what that's for. And let's go ahead and give the signature. Well, we already know the signature here. So these are the parameters that are passed into our lambda function here. So let's give them a name so we can access them. So start position, end position, double. Current local time, animation local length. Now remember, this interpolation event gets called when you're interpolating between each and every keyframe. Okay, so that's why you give the local time and the local animation length. And then we'll get the return. Okay. So very simple. A vector2 has two values, an x and a y, for the position. So it's very, very simple. We're going to take this return here. So p return, and we're going to take the x of it. And we're going to say, well, return value of x is very simple. We're going to access the math utils, okay, of Snappy here, and we're going to lerp. We're going to lerp. And because we need a very granular return, we need to use the float, not integer. Okay, so vector2i is a bunch of integers, and the lerping between integers is not as good, as fine-grained as lerping between floats. So we'll use the lerp f to lerp float here, and we need the start value, the end value, and then the percentage. So if I have, let's say, I give it 0 for the start and 10 for the end, and I give it a percentage of 0.5, that means I'm going to get a value of 5 back. So the percentage is at what point between the two values do you want to get. So if I say, well, I have 0 and 1, okay, and I give it a 0.75%, what I'll get is a 0.75 value between 0 and 1. So there we go. That's how that works. So we're very simply going to pass in the start value here. Start position dot x. The end is going to be the end position dot x. And what's the percentage going to be? Well, this is why it passed in the extra parameters. The percentage is very simple. How far along is the current time in the total animation length, or the local animation length? Very simple. So the percentage is the current local time divided by the animation local length. You understand that real quick? You understand that? So if I am, the animation local length is 1 second, so the time between these two keyframes is 1 second, and I'm like 0.25 seconds into it, while I'm only 25% of the way done. Pretty simple. Beautiful. Now let's go ahead and take the y. Now this is my own lerp function here. If you guys probably understand linear interpolation. You can use your own custom. You can use different types of interpolation if you want to do. But I just stick with my linear interpolate. But you could use any interpolation that you want. So now we'll interpolate the y value. start and end, and a percentage, and bada bing, bada boom. So, very simple. Let's go over this. First, we create our animatable value, and we have it a vector2 type. We want to animate a vector2i, okay, integer. The constructor we pass 0.5 seconds. We want the animation to be a total length of half a second, and we don't want any looping at all. Next, we get the window, the current active window in Snappy. We then take that window and get its current screen space position. See, get handle position is the screen space position of our window, okay? So we got it, bam, we know the original position. Then we take our animation here and say we're going to add a keyframe at keyframe 0, and we're going to store the original position. Next keyframe at quarter of a second, we're going to say, hey, you're going to be up on the Y, okay, by 100 pixels. And then the last keyframe at half a second, which is the end of the animation, we're going to say, hey, you're back at your original. So it's going to go up and then down, okay, within a half a second. Beautiful. The next what we do is we say, hey, you may not know how to interpolate the vector2i, so let me do it for you. Here's the interpolation event, and here's the lambda function that will get called every single time we need to interpolate. And what we're going to do is we're going to say, hey, we're going to return the new value. And I'll tell you why we return, okay? Because we could basically, what we're going to do is set the new position in this interpolation. So every time we interpolate, we're going to set the new position. But you don't have to do it that way. And I'll tell you why we give it the return, okay? So we're going to say the return x and return y. We're going to linear interpolate. So we're going to take the current, so we're going to take the position where it needs to be, and the end position where it needs to be, and we're going to interpolate through a percentage. Okay, so as time progresses, we'll get further and further along in percentage. And here's your new value. Bam, bam. Okay. Now, here's why we give it the return value. We're not going to use it in this tutorial, but it's very useful, and this is probably the most likely way you'll be using this system. Okay, because a lot of times you may not want to do something at that particular interpolation, but you'll still need to know what the current value is. So very simple. At any point in time, okay, you take the position anim, and then you can basically say get current value, and this will return the vector2i here. Okay, gets the current value of the target of the animation. So at any point in time while your animation's going and going, outside of the class or inside of the class, you can use this get current value. And since all animations occur asynchronously, okay, not on a different thread, not on a different thread, but they are asynchronous. Okay, so they are updated every frame, so they're not blocking. So you can keep doing stuff. So animations will continue to run. They're not blocking. So you can use this get current value. And you'll always know what the current value. Okay, it's absolutely beautiful. But we're not going to use that sort of function call in this one. We're actually going to do something. Okay. Now that we know what our new position should be, let's go ahead and do that. We have our main window up here, and we need to set its position. But now we're in a lambda here. How the heck do we get access to that outside variable in this lambda function? Well, if you guys know the lambdas, you basically add a capture here. So this right here in the lambda function, this opening and closing brackets, is a capture list. Anything you put in here will be available inside the lambda function. So outside variables will now become inside variables that you can access as well. You can do this two ways. One, you can just put a reference symbol, and that means that everything on the outside will be accessible within the function. Or you can be very specific, and I say, well, I only want the main window to be accessible. So now I got that. So P, main window, very simple. Set position. Oh wow, that was easy. What position? Well, the P return. It takes a vector2i. There we go. So every single frame, we get this callback on interpolation event. We tell it where the window should be just by simply interpolating between the start position of the keyframe and the end position of the keyframe. By the way, if you want a little bit more information, I'll give that to you. The start value, where does that come from? Well, the start value is the keyframe, your last keyframe. What is the value at the last keyframe? The end value is what the value is at the next keyframe. That's what that is. So for the entire keyframe's worth, start position and end position will be the same value for the entire keyframe. They won't be equal to each other, but they will be. So let's say this event gets called 30 times within one keyframe. Start position will be the same as it was those 30 times. End position will be the same as it was 30 times. So the start value okay, start value, is the last keyframe, what the value is supposed to be, and the end value is the value of the next keyframe. The current local time, obviously, is how much time in seconds between last keyframe and current keyframe. How that's calculated is basically the start keyframe, so the keyframe you are starting from will have a current local time of 0, and then the end keyframe will have whatever the animation length is. Okay, animation local length again is the amount of time in seconds that are in between two keyframes. Return, like I said, since events cannot return values, at least with my system they can't. There's really no practical way of doing that. We provide a reference parameter, okay? So we give it the return. And that's what we're doing. So we're literally interpolating. I spent a little bit too much time on that, but I just wanted to get across how easy and how cool that interpolation event is. So now that we have that set up, beautiful, okay? Again, this is an event, so you don't have to use a lambda. You can use a predefined function, a member function, a static, a global, any function you want, as long as it matches the interpolation event signature. Okay, so vector 2's I is not the signature statically, but we told it the intermediate value is going to be vector 2. That's why it's a vector 2i here. So as long as you match the signature, okay, of the interpolation event, you can have any sort of function, lambda, member function, global, all that, okay? And that's it. So for the up, all we do is we've added all the keyframes, we told it how to interpolate. Last step, very simple. Very simple, huh? Play. That's it, it'll continue to play. As you can see, after we get out of this, after we play, what would happen is it would reach the end of the scope, and because it's a local variable, the intermediate value would basically get destroyed. So we actually have no animation at all. That's why I made it a dynamic variable. Of course, we will get a memory leak, but that's fine. We're in debug mode in Visual Studio. So that's why I made it. So that way we don't get destroyed at the end of the scope. Normally, you would have to, I would definitely recommend you do not create on the heap unless you have a way of deleting it, okay? So there we go. So now we have the up. Very simple. So now let's quickly create the next three. So left, right, and down. So up, down, left, right. And they're exactly the same, right? Except for we add different positions here. So up, this one's going to be down. So E key down, right? So E key down. And everything's going to be exactly the same, except when we're going down, we're actually going to add 100 to the Y position, right? Okay. And on the E key up, we're actually going to do left. And when we go left, we're actually going to minus on the X, right? So X is left and right, so 100, and we're not going to do anything on the Y. Beautiful, we'll copy that here. And then when we go right, okay, we're going to do the exact same thing as left, except we're going to add 100 on the X. Very simple. How about we get started? Okay, so let's go ahead and click on play. And give it a little bit of time to compile. Ah, beautiful. So what we'll do is I want to first, we'll add that text scrolling, just to have a nice cool background effect here. You can see me roll it around. But here's what happens when we press up on the keypad. Ready? So up. See how it went up? The whole animation was a half a second. And a quarter of the second way through it was up. Then a quarter of a second later it was down. So we go up and down. Pretty cool, right? You notice that the animation, the multi-keyframe animation text that's animating is also relative to the position. So that still animates properly even though the window is moving. Beautiful, correct? I think so. All right, we'll go right. Look at that. Very nice. I just pressed it 3 times, by the way. So go down once, whoop, down again, whoop, down again, whoop, left, 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 up, up. It doesn't really matter where the window is. So we'll go up again, up, left, left, right, down, up. Pretty cool, right? Nice. I think so. Ooh, and let's exit. So yeah, I just want to go over that one more time, just so you have a clear understanding, crystal clear. So let's just do this up here. So what happens is we create an animatable value, which is basically the only animation class. We tell it that the type of value we're going to be animating is a vector2i, so a vector2 int. We then tell it in the constructor that we're going to be a half a second long animation, and we're not going to do any sort of looping at all. Okay, I'll show you. Actually, I'll show you what looping is after I explain this here. Well, I know you know what it is, but I'm going to explain you what that looks like and show you that it works here. So then we get the main window. Okay, the main window is the currently active one. So in Snappy, the very first window that you create will automatically be set as the main window. Any subsequent windows that you do create after that, you'll have to set the main window. If you want them to be the main window, you'll have to get the application and set main window and pass that window in. The next line, we get the original position of the screen space position of the main window. We then get 3 keys. So we take the animation, we add a key, one at 0 seconds, one at 1/4 second, and one at half a second. So original position, 100 pixels above, and then back to down. We then tell it to interpolate, and the values that get passed in is the where it started from, okay, where the animation started from, where it ends, okay, the value. The current local time is the amount of time in seconds that have passed since the last keyframe, okay. The animation local length is the amount of animation time in seconds that there are in between the keyframes that you are animating, okay. We then tell it to interpolate between the start value and the end value by how far along we are in the animation keyframe, okay, so X and Y. And then we set the position, okay, to the new position, the interpolated position. We then tell it to play the animation. And this is an asynchronous deal, so it won't block. So animation will play while you can do other things as well. Beautiful. Okay, so I'm going to show you here what the looping looks like. So it's going to go up and down, up and down, up and down, up and down after I just press it once. Okay, and I'll show you that here. All right, so I'm going to press up. So you can see what's happening there. It's looping. Let me see if I can close the window while it's... I missed. Let me try it again. Come here, window. Boom, 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 boom. Gotcha. All right, then. Thank you guys very much. I hope you enjoyed, and I hope you appreciate the hard work I've put in into the animation system here. If you guys have any questions about the animation system, just drop me a line, okay, on the YouTube channel. Thank you very much. Hope you enjoy.